Video 51, Choosing the Right Statistical Test Area for MCHES Sub-Competencies 4.4.1. Review the learning objectives for this video. Choosing the correct statistical test is a critical skill for the MCHES exam, and here is the good news. It is more straightforward than most candidates expect once you know the decision rules. I am going to walk you through them clearly so you feel confident with this. The test you choose depends on a few key factors. First, consider the number of groups you are comparing. Are you comparing two groups, such as a treatment group and a control group, or are you comparing three or more groups, such as three different intervention conditions? The number of groups determines whether you use a t-test or an analysis of variance. Second, consider the type of your dependent variable, which is the outcome you are measuring. Is it continuous, meaning it can take any value along a scale like blood pressure, test scores, or weight? Or is it categorical, meaning it falls into distinct categories like yes or no, male or female, or smoker, former smoker, or never smoked? The type of dependent variable is the most important factor in selecting your test, so pay close attention to this one. Third, consider the type of your independent variable. In most health education research, the independent variable is categorical, representing group membership such as treatment versus control, but sometimes you want to examine the relationship between two continuous variables. Fourth, determine whether your data meet the assumptions required for parametric tests. Parametric tests, which include the t-test and analysis of variance, assume that data are normally distributed and that the groups have approximately equal variance. If these assumptions are not met, you may need to use non-parametric alternatives. Fifth, clarify your research question. Are you comparing groups to see if they differ, or are you examining the relationship between two variables? Comparing groups calls for t-tests, analysis of variance, or chi-square. Examining relationships calls for correlation or regression. Once you have these 5 factors in mind, the right test practically chooses itself. When your research question involves comparing group averages and your dependent variable is continuous, you use either a t-test or an analysis of variance depending on the number of groups. Let me break these down for you so you can see exactly when to use each one. The independent samples t-test compares the means of two different groups. For example, comparing the average blood pressure reduction in a treatment group versus a control group. The two groups consist of different participants. The paired samples t-test, also called the dependent samples t-test, compares means from the same group measured at two different times. For example, comparing participants' pre-test scores to their post-test scores. The same individuals provide both measurements. The key distinction on the exam is whether the two measurements come from two different groups of people, which requires an independent samples t-test, or from the same people at two time points, which requires a paired samples t-test. Analysis of variance, abbreviated as ANOVA, extends the comparison to three or more groups. If you are comparing three different health education interventions, such as a lecture-based program, an online program, and a peer-led program, you use ANOVA because you have three groups. Here is a common exam mistake that I want to help you avoid. Some candidates think you can just run multiple t-tests when comparing three or more groups. Running multiple t-tests inflates the chance of a type 1 error. ANOVA is designed to compare all groups simultaneously in a single test, maintaining the correct error rate. One way ANOVA has one independent variable with three or more levels. Two-way ANOVA has two independent variables, allowing you to test their individual effects and their interaction. If ANOVA reveals a significant overall difference, post hoc tests such as Tukey test are used to determine which specific groups differ from each other. ANOVA only tells you that at least one group is different, not which ones. You are putting together a really clear decision framework here, and that is exactly what the exam rewards. The chi-square test is used when your dependent variable is categorical rather than continuous. Specifically, chi-square compares observed frequencies, meaning the actual counts in each category, to expected frequencies, meaning the counts you would expect if there were no relationship between variables. For example, suppose you want to compare smoking quit rates between a treatment group and a control group. The outcome is categorical, either the participant quit or did not quit. You cannot calculate a mean for this type of data. Instead, you count how many people in each group quit and how many did not, and the chi-square test determines whether the proportions differ significantly between groups. Here is a simple rule that is going to save you time on the exam. If your outcome is measured in counts or categories such as yes versus no, pass versus fail, or low risk versus moderate risk versus high risk, use chi-square. If your outcome is measured on a continuous scale such as test scores, blood pressure, or weight, use a t-test or ANOVA. Pearson correlation, symbolized as R, measures the strength and direction of the linear relationship between two continuous variables. Unlike the test we discussed earlier, correlation does not compare groups. Instead, it examines whether two variables move together. The correlation coefficient ranges from -1 to +1. A positive correlation means that as one variable increases, the other also increases. For example, physical activity and cardiovascular fitness are positively correlated. A negative correlation means that as one variable increases, the other decreases. For example, physical activity and body fat percentage are negatively correlated. A correlation of 0 means no linear relationship. The closer the correlation is to -1 or +1, the stronger the relationship. Values near 0 indicate weak or no relationship. And here is something important that I want you to always keep in mind. Correlation does not imply causation. Even a strong correlation between two variables does not prove that one causes the other. A third variable may explain the relationship, or the direction of causation may be unclear. You have now covered all the major statistical tests for the exam. That is a tremendous amount of ground, and you should feel really confident about your ability to match the right test to the right scenario. Read the scenario stem aloud. Give students 30 seconds to consider options before advancing. The correct answer is C. One-way ANOVA is the correct test because the health educator is comparing the means of three groups: full participation, partial participation, and no participation on a continuous dependent variable, number of sick days. Option A is incorrect because an independent samples t-test is only appropriate for comparing two groups, not three. Using multiple t-tests would inflate the type 1 error rate. Option B is incorrect because the dependent variable, sick days, is continuous, not categorical, making chi-square inappropriate. Option D is incorrect because correlation examines the relationship between two continuous variables, while the independent variable here is categorical with three group levels. Summarize